Okay, so here are the first three definitions. Mode, mean, median. This should not be new. You should have seen this before. This should look familiar. So now we've got this set of data. And first of all, I need to know what is a line plot. So somebody raise your hand and tell me what you got for a line plot. Zach. Simple graph that helps us see a relationship between data. So a line graph, a line plot, sorry, there is a difference. We can see one here. We've got X's. Each of those X's is going to represent one movie theater. The whole thing is showing us how many theaters sell tickets for a certain amount of money. So 2 area theaters sell their movie tickets for $6.50. 6 theaters sell their tickets for $7.25. And 4 theaters sell their tickets for $8.50. That's what this graph means. So now, for this graph, we want to find the mean, median, and mode of the data that we are given. So again, this is why it's extremely important to use your book. Because what it looks like up here is, oh, I have 3 data items. I'm going to add them together and divide by 3. But what we need to remember is each of these X's represents one data item. So I'm not just talking about 3. I have a total of 12 data items. So we have to take 2 times 6.5 because that happens twice. We have to take 6 times 7.25 and 4 times 8.5. Then we add all of those values up, and Greg got 90.5. And then we divide that by 12 because there's 12 total theaters that we looked at for this problem. Now, what are we talking about? What kind of data? We're talking about dollars. So I do want you to make sure that you label your answer. Anytime we can give our answer a label, we want to do that. Here, we're talking about money. We're not talking about watermelons. We are talking about money. So give your answer a label as often as you can. All right, the next thing that we need to find is the median. Okay, so we notice that the first thing that Zach did when he was up there is he put these into order. So that's the first thing that we have to do is put them in order. Now, some people, because our data was already in order on the graph, just use the graph to cross things off. And that's okay. You could just cross off the X's up here until you get to the middle. I actually wrote them all out and did it this way. It doesn't matter. You can do it either way. They're already in order on your graph. But here, let's check and see. So we notice we can just cross things off. So I'm going to cross 1 off at the beginning, 1 off at the end. 1 at the beginning, 1 at the end. Beginning, end, beginning, end, beginning, end. How many values am I left with in the middle? 2, because I did not mark this one off with red. This one is still here. So because I have an even number of data, I'm going to have 2 values that fall in the middle. So on your front slide, what do I have to do when I end up with 2 in the middle? Zach? So I'm finding their, it's in words on your first slide. I'm finding their mean or the average. So we can call it the mean, we can call it the average, but I have 2 values, so I need to find their mean or their average. Now, what's special about this problem? What do we notice about these 2 values? They're the same. So my median is going to be 725 because it's the same value, but to calculate the average, I add them together and divide by the number of data items, and because it is the exact same value, their average is going to be 725. Give your answer a label. We're talking about money. So the median here is 725. Ordered list, and then find the middle values, or value. Now we have to find the mode. And I can simply look at this graph and figure out what is my mode. Jacob? It's 725. How do we know that? It has the most. Mode means most. Which one occurs the most often? There are 6 theaters that sell their tickets at $7.25. I only wish this were true. I think it's more like $9 anymore. Ridiculous. But in this problem, we did some area theaters. And the most theaters sold their tickets for $7.25 a piece. Drive-ins are pretty good value because you get 2 movies, and it's usually cheaper than going to the theater. Any questions? Questions about this problem? Mean, median, modes, line plots. All right, let's move on to a bar graph. What is a bar graph? Graham. So we use bar graphs when we want to compare things. And this second set of lines, you did have to look in the actual example. So we had to go into example 2 on our book. And what did we find to fill in the rest of those blanks? Jason? And then the second set, a blank bar graph must include a blank. Did you find that one under example 2? Dante, did you find that one under example 2? What'd you get? And what was the first blank? Okay, so when we have a multiple bar graph, we have to include a key. And we see that in this example. We have multiple colors, multiple values that we are comparing. So I have to include that key so I know what I'm talking about. So now let's go down to these very small questions. Hopefully you saw them. If not, we're going to talk about them now. So first of all, let's think on a coordinate plane. So think about ordered pairs, coordinate plane. We have a vertical and a horizontal scale. And I want to know, in a coordinate plane, which axis is going to go vertical? Seth? Which one goes vertical? Alex? The y-axis. Good, because we're going to talk about that too. This is just kind of a side note. The vertical scale or axis represents the y-axis, which means horizontal, which goes straight across, is the x-axis, or the horizontal axis when we're talking about graphs. So now let's think about in this graph, what is the horizontal or the vertical scale, and what does that represent? Jacob? So it represents the number of students. That is going to come into play when we actually talk about what is the scale. So what value does this scale have? Where do we start and where do we stop? What'd you say, Alex? So it goes from 0 to 4. What? I didn't hear the rest of that. Okay, because we're talking about in millions. That's where that comes into play. Our scale represents the number of students, and we start at the bottom at 0, and it goes up to 4 million. That is a lot of kids, but we're talking about the entire state of Illinois, not just one school. So now let's take a look at the horizontal scale. So what is the horizontal scale, and what does that represent? Seth? Okay, so it represents the grade level. And what is our scale? Where do we start? Where do we stop? Are we talking about every grade? Are we talking about college? What are we talking about? Jacob? 9th through 12th. So our actual scale, we start at 9th grade and we go through 12th grade, and it represents the grade level of the students. So now let's look at this graph. Do we see a trend? Do we see something that is consistently happening in this graph? Okay, somebody raise your hand and tell me something we see. Joe, what do you see? In every single one of these, we have more students in the year 2000 than we did in 1990. So it's safe to conclude that over time, the number of students in Illinois has increased. Do we notice any other trends in this graph? Anything else that happens consistently? Jacob? Graham, did you have something? Okay. Okay, so in 1990, every single grade level increases. In 2000, almost every grade level increases. Except, 11th grade is the highest in 2000. So fairly consistently, we can see that the higher the grade level, the more students there are. Now that doesn't happen all the time, but most of the time, that is a true statement. So trends, we're just looking for what is consistently happening in these graphs. Let's take a look at line graphs. So again, we need to remember line graphs and line plots are two completely different things. So a line graph helps me with what? Zach? How a set of data changes over time. So a line graph, we are comparing time. So now let's talk about our scales. Again, vertical scale goes with the y-axis, horizontal goes with x. So let's think about in this graph, Seth, what do we have? And what's our scale, Seth? Where do we start and end? $0 to $35? 35,000. So again, this is where that becomes very important. Our scale goes from $0 to $35,000. What about the horizontal? Jacob? So it's representing years. We start at 1991 and go up to 96. What trends do we see? What do we see happening in this graph? Will, what do you notice?
Increases, then flatlines, and increases.
So overall, it's mostly increasing, but we do see this one spot on our graph where it stays the same. But for the most part, we are increasing over time. So, and we would hope so, because if we're talking about an investment, I hope if I make an investment that it's going to grow over time. If it's not, we've got a problem and I need to invest in something else. So it's always a good idea if you have an investment, and a lot of times you'll have someone to help you to keep track of it, but you want to keep track of your investment because if it's not growing and increasing, you probably don't have a very good investment and you need to think about doing something else with your money. You don't want to be losing money on an investment. Probably. Questions about this? All right, we are done looking at graphs. This is another problem I have for mean, median, and mode. I want you to give me a thumbs up if you think that we need to, if you think you understand mean, median, and mode. In the middle? So do we think we need to do this problem? Let's just quickly kind of review. How do we find the mean? Zach? Add them all up and divide. So these are decimals. I'd use a calculator for this one. Add all those numbers together and then divide by 1, 2, 3, 4, 5, 6 and get your answer. How am I going to find the median, Seth? What do I need to do first, Alex? Put them in order. So the first thing I would need to do is put them in order. This is very close, except this 9.5 would need to go right here. Everything else is in order. Whoops, forgot the 8.1. And then we start crossing out, so beginning, end, beginning, and then I end up with 2. So how do I find the median when I get here? Jacob? Actually, I think it's exactly equal to So again, we have two numbers in the middle, so we have to find their average to find the median. So we get this number. What is the mode of this data set, Seth? The most, and what value? In this problem, there is no mode. They all occur exactly one time. And when they all occur the exact same amount, there is no mode. There's not one that occurs more than any others. We feeling better now, Graham? Yes? I know that was very quick, but hopefully that just kind of gave us another example. I don't think it's a bad thing to see. This one does work with decimals, which is different. So hopefully we have all of those examples now for those types of problems. All right, section 1.2. All right, so here are our definitions. You should all know a variable is a letter. We use it to stand for a number. A variable expression must have at least one variable. Term is a number of variable or a product of numbers and variables. That is important. This, we have to have either just a number or a variable or products. As soon as we put addition, subtraction, or division, that means we're breaking it into more than one term. Multiplication is the only thing that is okay to see in a term. No other operations. And then an equation means that two expressions are equal. So now I want to look at an expression and an equation, and I want someone to tell me the key difference between those two items. Jacob? One has an equal sign. An equation must have an equal sign. An expression will not have an equal sign. Again, if I write something down, it's important. You need to make sure that you are writing it down as well. This will come up. If I ask you to write me an expression, do not put an equal sign or it will be wrong. If I ask you to write an equation, you better have an equal sign. Some key words that we see. With an equation, we're going to see the word solve. We can come up with an answer. We can solve for our variable. With an expression, we can simplify. So expressions, we simplify. They do not have an equal sign. Equations, we solve. So a variable expression, we will not come up with an answer. We won't get x equals, y equals. We'll just simplify it as much as we can. Equations, we can come up with an actual answer. Now let's look at these problems. And I picked these problems because they are very, very similar to the ones in your book. So, if you had me last year, you know how important it is to me for you to define your variables. Tell me what they mean. If you want to use x and y every time, use x and y every time. If you want to pick random letters, pick random letters. I picked letters that kind of made sense for the problems. By the way, revenue means kind of a total. Revenue means you are making money. How much money did I make? I'm selling tickets. Each of them cost $3.50. How much total money am I going to make from selling these tickets? Let's think about something that just costs $2. If I buy 2 items that cost $2, how much money am I going to spend? $4. What if I buy 10? 20. What am I doing with those numbers? Multiplication. So if I'm talking about selling tickets and I want to know what the total cost is going to be, what operation do I need to use? Multiplication. I'm just going to write that down. So we know when we write this equation, I better see some multiplication in there. Now, I use the variables R and T to represent my values. I use R to represent the revenue. I use T to represent the number of tickets. Make sure you have it defined like this on your sheet. Some of you wrote your equation, and in your equation, you kind of branched off and told me what they mean. I want to see it like this, so I can see exactly what your variables mean and they don't get in our way. So we've got revenue, we're selling some tickets. Now I need to write my equation, which means I have to have an equal sign. Joe, you want to write it? Perfect. Come write our equation for us. Fantastic. We just said if I buy 10 items and they're $2 each, I multiply it together to get 20 total dollars. So if we sell T tickets and they're each $3.50, multiply that together, that will tell me how much money I'm going to make. Questions about that one? Great. Let's go down and look at it at something written in a different way. So now I don't have words, I have a chart. And I want to take the information from this chart and write an equation. So first of all, we've got to label our variables. I, again, used H and P. I said that H was going to represent the number of hours, and I said that P was going to represent the total pay. You could have used X and Y, A and B, W and T. I don't care what you use, but just let me know what they mean. So again, I have to have some sort of equation. So let's look at our graph. What pattern do we see? Zach? Okay, for every 4 hours you get $20. Yes, I think I can simplify that even more. Jacob? Okay, that's exactly what he just said. Greg? Every hour you get $5. So what am I doing to each of these values to get to my pay? What am I doing to this 8 to get to 40? Multiplying by 5. If I multiply 12 times 5, I get 60. 16 times 5 is 80. 20 times 5 is 100. So each time, so that's what we said, for every hour I work, I get $5. So what is my equation going to be? And what order do I want to write that in? When I'm multiplying, what do I want to put first, the number or the variable? The number. So we would just want to write that as 5H. Standard form of an equation, we want to put the number first if we're multiplying. So I multiply 5 times the number of hours I work, and that'll tell me how much I'm going to get paid. $5 isn't very much, but I guess they don't have to pay taxes, so that helps. True. Questions about either of those? We need to look at words and be able to write an equation. We need to look at tables and be able to write an equation. Look for patterns. I do want to go over, I want to look at example number 1 right now. So I want you to write this down. If you have some room on your paper at the bottom, off to the side. If you want to do it on a separate sheet of paper, get out a separate sheet of paper, but somewhere I want you to write this down. So here, we are talking about, I want to identify what are the variables, what are the terms, and then how many terms do I have. So, someone want to volunteer to come write the variables? Joe, go write my variables for me. Perfect. Who wants to write the terms? Jacob, go write the terms for me. I would go with -6. Sign is important. But I also think you're missing something. Zach, what's he missing? When we're listing the terms, that includes the product. So that includes the coefficient and the variable. So let's make sure that we're writing those correctly. It is a number, a variable, or the product of a number and a variable. There we go. Sign is important, and we want to make sure that we include everything. So Jason, how many terms do I have? 3. Make sure you get all of this information written down. We need to identify variables, identify the terms, and be able to say this is how many terms there are in this expression. Questions? Yes. Yes. And we would include the exponents when we're listing the terms as well. So terms are, we've got a squared, we've got b squared, and we've got -c squared. So we still only have 3 terms, but we do have to make sure we include those exponents and the sign.